Okay, section 8.8, systems of linear equations. So far we've been graphing linear equations on one linear equation on each coordinate plane. Now we're going to start graphing more than one, and that's what's going to make our system. So a system of linear equations, or a linear system, is basically two or more equations. If you think about like a computer system, your operating system, usually a system involves something that requires more than one. So that's a nice way of remembering. If I say linear system, we're talking about linear. Obviously, it's going to be a straight equation of the form y equals mx plus b. And then system is going to imply that there's more than one, so two or more. For our purposes, we're only going to work with two equations at one time. Now, a solution of a linear system is whatever ordered pair is true for both equations, or whatever equations you're working with. So an ordered pair that satisfies all equations in the system. So if we think back before we go on any further, whenever we graph an equation, let's just say, whoa, let's say we graph this equation here, and this line looks like this. Every point on this line is a solution. All the ones in between, there's infinite number because we get into all the decimals. Every single ordered pair that falls on this line is a solution to whatever the equation is. This equation, let's say it is y equals x plus 1. So any ordered pair that falls on this line is a solution to that equation, meaning you could substitute it in and it will work. So this point here, 0, 1, if I substituted in 1 for y, 0 for x, I get 1 equals 1, and we see that it's true. And that would work for any other point on this line. So any point on a line is a solution to the equation. Well, when we have a linear system, when we have more than one line, we are looking, let's say we have this line here, our solution is going to be any point where they both intersect, because that's the only point. If we say, we can't say any of these are solutions to the system because these points only fall on the blue line. We can't say any of these red points are solutions to the system because they only fall on the red line. But this point where I kind of blobbed it out real thick and dark, this is a solution to the linear system because it falls on both lines. It's a point that we could substitute into both equations and it will work. So let's take a look at example 1 to clear some of that up and get a little more in depth. Here's our linear system, y equals 2x minus 4 and y equals negative 3x plus 1. First, we're going to graph the equations. So my m here is 2, my b is negative 4. I'm going to go to negative 4 on the y-axis, because that's my y-intercept, so y next. Negative 4 on the y-axis, and then up 2 over 1, up 2 over 1, on and on and on. So this, well, I'll make that as straight as I can, is my first equation. Now my second equation, my slope is negative 3, and my y-intercept is 1. So now I'm going to go up 1, down 3 over 1, down 3 over 1. And I could have gone up 3, but to the left 1. And when I do that, my line looks like so. So the only point that they both share, that they have in common, is this point right here, which is the point 1, negative 2. That would be our solution. Identify the apparent intersection point. It's 1, negative 2. That's where they both cross. So this means this is the only ordered pair that is going to make both of these equations true. So in step 3, let's verify that that is a solution. So my first equation was 2x minus 4. I'm going to substitute, because this is x and then y. I'm going to put 1 in for x, so 2 times 1 minus 4, and negative 2 in for y. I get negative 2 equals 2 minus 4, negative 2 equals negative 2. So it is a solution to this first equation. Now I'm going to check my second equation, negative 3x plus 1, again substituting in the same point because that's the one we're saying is the solution to the system. I get negative 2 equals negative 3 plus 1, negative 2 equals negative 2. So this again is a solution, which we can see by the graph. It follows both lines cross through that point. So our solution to this linear system is 1, negative 2. There can't be any other points because there's no other points where they're going to cross. Let's try this one here. We have two equations, y equals x plus 1. Here my slope is 1, because it's 1x, so it's 1 over 1. My y-intercept is 1. I'm going to go ahead and graph that. I'm going to first go to my y-intercept, then up 1 over 1, up 1 over 1, up 1 over 1, and we get this nice, just like this, okay? And I'll connect those pretty straight. And then my second equation is y equals negative 0.5x minus 0.5. I'm going to rewrite this as negative 1/2 x because we know our slope has to be a fraction. So 0.5 is 1/2, so let's just do that. And I'll write that as negative 1/2 too. But they're exactly the same thing. My slope is negative 1/2. My y-intercept is negative 1/2. First, I'm going to go down 1/2 because that's my y-intercept. Then my slope from here, I have a rise of negative 1 and a run of 2. So I'm going to go rise negative 1. So I go down a whole block and then a run of 2. 1, 2. Notice I'm like in the middle because I went down a half initially for my y-intercept. Down 1 over 2. Over here I'm going to go up 1 over 2. Up 1 over 2 and so on. So when I connect these, and again, I would recommend that you use a ruler of some kind instead of a unsteady hand using this pen that I use. But we see that there's a point where they intersect, which is right here. And this is the point, oopsies, negative 1, 0. It's negative 1 on the x-axis, 0 on the y. So the solution is going to be negative 1, 0. Now we have to test it just to make sure, because you never know. Sometimes you think you're right, but then you substitute it and it doesn't work. That's why using a ruler is so important. So y equals x plus 1. I'm going to put negative 1 in for x, 0 in for y. Test it. 0 does equal 0. For the second one, I have y equals negative 1/2 x minus 1/2. I'm going to put negative 1 in for x and 0 in for y. So negative 1/2 times negative 1 is positive 1/2 minus 1/2. I get 0 equals 0. So that is a solution, I mean. So our solution here is negative 1, 0. All right, let's take a look at the next page.